This is my third video tutorial for my Calc 1 class, and it's on section 2.4, one-sided limits and limits at infinity. But let's look at one-sided limits. Okay. Now remember what I told you before, that when you want to check whether a function goes to a certain limit as x approaches a certain number, what you do is you take your x and you approach that number from left and right. And regardless of whether you approach it from left or whether you approach it from right, if the function seems to be heading towards one single number, then we say that that is a limit. And if it approaches one number when you approach from the left and approaches another number when you approach from the right, then we say that the limit is not there. But still, you could talk about a left limit and a right limit. So let's talk about what you mean by a left limit and a right limit. Okay, so take a look at this function. This is actually the function which is called x divided by the absolute value of x. And this function takes a value 1 when x is positive, and it takes a value negative 1 when x is negative. So now let's try to see whether we could try to find the limit as x tends to 0. Okay. So in order to do that, let's try to see whether let's approach 0 from the left. So when x is approaching 0 from the left, what is happening to the graph? The graph is at negative 1 and it keeps at negative 1, right? And as x grows close to 0 from the left, the graph is going to negative 1. Right? Once again, we are not worried about what happens at 0, we are only approaching 0 from the left. It's going towards negative 1. Somebody might say, hello, now at 0 it is not negative. No, we are not worried about what happens at 0, only what happens when you approach 0 from the left. It is heading towards negative 1. And if you approach now from the right, okay, so we are approaching 0 from the right, so x is approaching 0 from the right. So x is here, say the value is 1. Come down here, value is 1. Come down here, value is still 1. Come down here, value is still 1. So approaches 0 from the right, the value keeps at 1 and it's at 1. So from the left, as x approach from left is negative 1, negative 1, negative 1, negative 1. From right is 1, 1, 1. So you can say that as x approaches 0 from left and right, the limit seems to be, or the function seems to be heading towards two different values, from the left negative 1, from the right positive 1. They are not equal, so because they are not equal, there is no limit. But we can still talk about a left limit. So we denote it like limit. Now x approaches 0 from the left. We put a 0 minus. So it's 0, and then after that we put a little minus sign, and this minus sign says that we are approaching 0 from the left. So when you are approaching 0 from the left, what is the limit? Is equal to negative 1. Okay. Likewise, if we are approaching x from the right, what's the limit? The limit is positive 1. So how do we write that one? Limit x tends to 0 from what? The right. So we have a 0 plus, not plus 0 or minus 0, but it's 0 plus. 0 plus means we are approaching it from the right. And what is that equal to? So we are approaching, then that is equal to what? 1. So the left limit is negative 1 when approaching from left. When approaching from right, the right limit is 1. So the left limit is negative 1. Right limit is 1. So that is the concept of the left limit and the right limit. So once again, this tells you the notation. If you're approaching c, this is a general function. If x is approaching c from the right, we put c plus. Can you see the plus here? Right, okay, right. So it's approaching towards L, right? Because x is approaching from, to see from the right, the function is approaching towards L. Can you see that, right? The y value. So if you're approaching x from the left, then where is the function approaching? Towards m. So left means c minus. Now remember, it's the number followed by the sign, not minus c or plus c. Okay. Another example, right? Let's look at this half circle. Now, uh, what is the right limit? Now, it's kind of a confusing thing. Be very careful, right? Suppose you are approaching negative 2. Now, negative 2, you can only approach from the right, because from the left there is no, the domain. Left is not, the left side is not there in the domain. So you're approaching negative 2 from the right. How do you write that? So negative 2, right? Can you see that? How they are written? Negative 2, and you're approaching from the right side. Negative 2 from the right side. Okay. What's happening to the function? So the y value is heading towards what? So x value is heading towards negative 2, y value is heading towards what? 0. So the right limit at negative 2 is 0. Is that okay? Right? Now let's look at positive 2. Now we can only talk about a left limit. Why? Because you can only approach positive 2 from the left. So now let's approach positive 2 from the left. So somewhere around here, what's the value? It's somewhere here, right? Okay, when you come close to 2, what happening to this value is coming closer and closer. The y value is heading towards, close to 2, it's heading towards what? It's heading towards, once again, the y value, right? The vertical value is heading towards 0, okay? Alright, so the left limit at 2, how am I going to write it now? It's 2 and minus, can you see? 2 and minus. This is 2 is the number, and minus means left limit is actually equal to 0. Alright. So the left limit as 2 is 0. Right, and the right limit as negative 2 is also 0. Are you okay? Alright, very good. So once again, this is a very important theorem. It says that in order for the limit to exist, then, you know, regardless of whether you approach from left or right, we must have the same limit. So if the limit has to exist, then the left limit, can you see the left limit? Right, and the right limit here, can you see the right limit? They are the same, right, and they have to be equal. They're both L. Can you see that? Left limit is L, right limit is L. So therefore, the both L, then the limit is actually equal to L. Alright, so let's take a look at this graph, and it's a good graph, and let's see whether we can figure out some of these limits. So if I ask you, okay, what would be the limit at say 0 plus? So if I go to 0 plus, right, so we are approaching 0 from the right hand side. So approach 0 from right hand side. Okay, look at what the y is. So y is heading towards what? 1. Can I say that y is heading towards 1? Right, is equal to 1, right? Now let's try to see whether what happens when you approach 1 from the left. So how do I write that? 1 minus, that means we are approaching 1 from left, okay? Where is the function heading towards? Heading towards 0. Then somebody might say, hey, you know what? The value at 1 is not 0, it's 1. So is it 0 or is it 1? Hey, we are not interested in what happens at 1. Remember that we are talking about the limits. We are only one concern about what happens when you are heading towards that. When you are heading towards 1 from the left, the function is heading towards 0. Can you see that? Right, 0, 0. Okay, now let's look at what will happen at 1. If you are heading towards 1 from right, so 1 from right. So if you're heading towards 1 from right, okay, so heading towards 1 from right, now where is the function? Function is here. Where is it heading towards? it is heading towards 1. If you are heading 1 from right, heading towards 1. So from the left to 1, it's heading towards 0. From the right to 1, it is heading towards. So the left limit at 1 is 0. The right limit as 1 is 1. Can you see? Is there a limit? They're heading to two different places. No limit at 1. So limit at 1, we just say limit at 1, it does not exist. Does not exist. So likewise, if you look at 2, what's the left limit? The left limit is 1. What's the right limit at 2? The right limit, hey, what is this? There's a 2 here, but that's the value at 2. We don't care about that. It is approaching 2 from the left, it is 1. So the left limit is 1. And the right limit is also where? It's heading towards 1. Can you see that right? Okay. So let's try to erase this one, right? Okay. So left limit. So once again, left limit is what? 1. Left limit is 1. Right limit is also 1. So the limit at 2, 2 plus is 1. Limit at 2 minus is also 1. So they are equal. Can you see? So the limit at 2 is also equal to 1. So the left limit is 1, the right limit is 1, the limit at 2 is also equal to 1. Okay, so that's it for today's one. Okay, see you in class.